When people say we need AI, they often mean very different things. So let's get precise by using one simple mental model. Three nested circles. The biggest circle is artificial intelligence. Inside that is machine learning. Inside that is deep learning. Each layer solves problems in a different way with different costs, risks, and strengths. Artificial intelligence, or AI, is the broad goal. It means building systems that behave intelligently, planning, reasoning, perceiving, understanding language, or making decisions. Crucially, AI does not have to learn. Many AI systems are built entirely from rules, search, and optimization. A scheduling system that assigns crews to flights, a route optimizer that finds the fastest delivery path, or a chess engine using search and heuristics are all AI. No training data required. These systems shine when the logic is stable, the constraints are clear, and explanations really matter. Machine learning sits inside AI. Instead of writing every rule by hand, you give the system data and let it learn patterns. The core idea is generalization. Learn from past examples so the model can make good predictions on new cases. If rules are messy, incomplete, or constantly changing, ML is often the right move. Think spam detection, fraud scoring, demand forecasting, or churn prediction. These problems usually involve structured, tabular data, like rows in a database. Traditional ML models rely heavily on feature engineering, where humans decide what signals matter. Algorithms like logistic regression, decision trees, random forests, and gradient boosting are common because they work well with modest data, train quickly, and are relatively interpretable. Deep learning lives inside machine learning. It uses large neural networks with many layers to learn features automatically. What makes it powerful is its ability to work directly with raw, unstructured data, text, images, audio, and video. Early layers learn simple patterns. Later layers combine them into complex concepts. That's why deep learning dominates tasks like speech recognition, image classification, machine translation, and modern chatbots. Large language models and generative AI systems are deep learning under the hood, typically built with transformer architectures. The practical differences show up fast. Data is the first one. Traditional ML can succeed with smaller or medium-sized structured datasets as long as the features are good. Deep learning usually wants much more data, especially during initial training, although pre-trained models in fine-tuning reduce that burden. Compute is the second difference. Classic ML often runs cheaply on standard servers. Deep learning can be expensive to train and serve, which is why teams use tricks like transfer learning, quantization, pruning, and distillation to cut costs. Interpretability is the third. Rules are easiest to explain. Simple ML models are next, and deep learning is usually the hardest, often requiring explanation tools and careful governance. In the real world, companies rarely deploy just one thing. They build systems. A customer support platform might use rules to route tickets, machine learning to predict priority, and deep learning to draft responses. Each piece earns its place. So, how do you choose? Here's a compact decision guide. If the logic is stable and must be auditable, start with rules or interpretable ML. If you're predicting outcomes from tabular business data, start with traditional machine learning. If the problem involves text, images, audio, or generation, deep learning is usually the right tool, ideally via a pre-trained model. And if you want an assistant that retrieves knowledge and takes actions, you're designing a full AI system that combines all three layers. Understanding these distinctions helps you ask better questions, estimate real costs, and pick the right tool instead of the loudest one.